Okay, the next several videos we're going to be looking at here are going to deal with rational functions. The first thing we're going to talk about is what is a rational function and what are asymptotes. We're going to have both vertical and horizontal asymptotes. And we're going to spend some time talking about rational functions. We'll probably do a couple what I would say application problems, and then we're going to wrap rational functions up and move into another class of functions. So just to kind of refresh, we talked about polynomial functions, we talked about their graphs, we talked about the zeros, and so we've kind of wrapped up our conversation on polynomials. That was one group or type of functions. Now we're going to move on to another type of functions, and these are rational functions. So let's go ahead and write a definition down. A rational function is the quotient of two polynomial functions. Okay, come on, there we go. Of two polynomial functions. So you can see why we would talk about polynomial functions first, and I even said that rational functions and polynomials are somewhat related, and the reason of course they're somewhat related is that a rational function is going to consist of two polynomials. And again, what we have here is that f at x is going to be n at x over d at x. So here of course n at x and d at x are polynomials. Now this is something that's interesting. Technically, all polynomials are also rational functions. In this case, d at x is just equal to 1. Now 1 is technically a polynomial. Now polynomials are also rational functions. Those are very kind of boring because we've already studied those. So we're going to look at rational functions where we don't just have like 1 or a 2 in the denominator. We're going to look at where we have x terms in the denominator. So polynomials that aren't just constant is what we're going to have for our denominators. Alright, so we kind of already know some of this just from our own discussion of domain and range of functions, but let's talk about finding the domain of a rational function. And finding the domain is simply, for a rational function, the rational function domain is going to be all real numbers except for x values that make d at x equal to 0. So what's key here is the domain of a rational function has nothing to do with the numerator of the rational function. So let's look at a couple examples real quickly of finding some domains here. So let's look at this here. So we're going to find the domain of the following functions. And I'll say, to emphasize, these are rational functions. So find the domain of the following rational functions. So let's first start with a relatively straightforward one. F of x is equal to 3x over x minus 1. So this is going to be, just to remind you, this is here, my pen's not changing, there we go. This is going to be all real numbers except for x that makes x minus 1 equal to 0. So really we just need to find when that's equal to 0, and of course that's pretty obvious. Just add 1 to both sides and you get x equals 1. So this is going to be domain is going to be all r except x equals 1. Now, let's look at another one here. So let's look at f of x is equal to x squared plus 1. Or actually, let's change this. X squared minus 1 over x squared minus 3x plus 2. Now, at a later point in the next couple of videos, we're going to talk about possibly sketching these graphs, and sketching them, we're going to possibly factor and reduce them. But the first thing we're always going to do on these, when we're looking at sketching a graph of these, we're always going to find the domain first. And we're not going to do any kind of simplification or anything, because this is the function we start with. So x squared minus 1 on top is irrelevant. Even though that would factor to x minus 1, x plus 1, that doesn't give me anything. So the domain here, again, this would be all r except when x squared minus 3x plus 2 equals 0. And of course, x squared minus 3x plus 2 factors to x minus 2, x minus 1, which is equal to 0. So we get that the domain is x equals 2 and I'm sorry, not x equals 2. It's all real numbers except x equals 2 and x equals 1. And of course, I did something. Okay, there we go. All right. So let's look at one more here. And let's look at f of x equals x over x squared minus 2x plus 5. So we know we're going to need to determine when x squared minus 2x plus 5 is. But that doesn't obviously factor. So, there still could be answers to it, zeros. They could be radicals, irrational ones, like 1 plus the square root of 5 over 2, something like that. But in order to do that, we'll apply the quadratic formula. So x is equal to, well, in this case, it would be negative 2, or a negative 2, so it's positive 2 plus or minus the square root of negative 2 squared minus 4 times 5 times 1 over 2 times 1. So we get x is equal to 2 plus or minus the square root of 4 minus 20 all over 2. So we get x is equal to 2 plus or minus square root of negative 16 over 2. Come on, I want to scroll you up here. Come on. I'm going to pause it until I can scroll it up. Magically, it's now scrolled up. All right, so we have 2 plus or minus the square root of negative 16 over 2, which this would be 2 plus or minus 4i over 2, which finally simplifies down to 2 plus or minus, not 2, 1 plus or minus 2i. Now the key thing here is this is, of course, a complex number that has an imaginary portion. Well, remember, we're looking at real values here when we're plotting these on the x-axis. We're only talking about the real values for x. So this is a complex with an imaginary portion. So what this actually means is there's nothing, no real number, there's no just purely real number that's going to make that denominator 0. So no real valued x makes x squared minus 2x plus 5 equaling to 0. So domain is all real numbers, because there's nothing that makes that denominator 0. So just because you've got a denominator with variables in it doesn't mean you're going to always get something that makes the denominator 0. Important thing to remember. Alright, last thing I want to talk about in this video, and then we'll talk about asymptotes in the next video, is zeros. Zeros of rational functions. So x equals a is a zero of a rational function if x equals a is in the domain of f at x and n at a equals 0. So finding zeros of rational functions is still going to be finding the zeros of the polynomial. The one key thing, though, that we have to be concerned about is that I've got to have this possible 0 here, this value a. It has to be in the domain of f at x. So that's why we first talked about the domain of rational functions. So, and as an example, let's kind of look at one that we were looking at here earlier. So we have f at x is equal to x squared minus 1 over x squared minus 3x plus 2. Now, I'm going to go ahead and just recall what the domain was. We did this problem earlier in this video. So the domain here was all real except x equals 1 and x equals 2. I'll say now we want to find the zeros. So we want to know when is x squared minus 1 equal to 0. Now this is a pretty easy one. This is just x minus 1 times x plus 1 equals 0. So we get x is equal to 1 and negative 1. But then remember, for a rational function, in order to be a 0, you have to be in the domain. But look, x equals 1 is not in my domain. So I don't have this as a 0. Even though it makes the numerator 0, it's not in my domain. We found the domain first, then you go for the zeros. And you always have to do that in that order. You have to figure out what your domain is first. In fact, in general, the first thing you should do when looking at a polynomial or a rational function is, or any function for that matter, is ask yourself, what is the domain? because the domain is a very important thing, because we can't have answers that aren't in the domain. And so the answer here, of course, is just simply that the zeros, and there's actually only one, the 0 of f at x is x equals -1. Now, in a couple videos here, we'll talk about how to graph these and using this kind of information, but right now we're just talking about getting the information from these functions here. So again, what we've talked about in this video is talking about how to find the domain, and then also how to find the zeros. Domain is all real except whatever makes your denominator 0, and then your zeros are all x values in the domain that make the numerator 0. So you figure out what makes the numerator 0, and then you verify that all those x values are in your domain. So in the next video, we're going to talk about vertical and horizontal asymptotes.